Hey everyone, this is a bonus video for Module 1, Section 2.3. I've been getting a lot of questions over this homework question, and so I made a similar example. I just changed the numbers here, and we're going to work through this. And so this is number 13 on the assignment, which I believe is the very last one. And so it says an open box with a rectangular base is to be made from a rectangular piece of cardboard 40 by 35 inches on a side by cutting out a square from each corner and turning up the sides. See the figure. Answer parts A through D. So they give you both of these two diagrams. So here is my flat cardboard rectangular board. It is 40 inches on one side by 35 on the other side. And so what they are doing is they're cutting out these 4 squares. And we don't know how big of squares we're cutting out, so we're just calling it X. So this could be a 2 by 2 square. This could be a 5 by 5 square. I'm not sure what the measurements are of these squares, but I'm cutting out these squares. And then I'm going to take these 4 sides and I'm going to fold it up along these dashed or dotted lines. And now I have a 3D box. So it is a box without a lid, essentially, an open box. And so the first thing we need to do is express the volume of the box as a function of length X of the side of the square cut from each corner. Okay, find the volume. Volume of a rectangular prism is length times width times height. So we need to figure out these 3 things. This right here is going to be my length. And that length is also going to be right here on my 3D box. So those are the same measurements. So I know this whole cardboard is 40 inches. And then I need to take away however big of this square we're taking out. But again, I don't know what that square is going to be. And so I've got the whole thing, 40 minus X, which is the same thing as 40 minus 2X. So my volume for the length is 40 minus 2X. So now we need the width. The width is going to be its perpendicular length. So same concept. The whole length is 35, and then we're going to subtract however big we're going to make that square. So 35 minus X, which gives me a width of 35 minus 2X. And then lastly, the height. The height of this box right here is going to be the length of that square. When you take that and you fold it up, that's going to be this length, that height. So your height is just simply X. Right, so this is your first answer. This is my volume of this open box. And that X is going to change depending on how big of squares we take out. So then part B wants to know what is the volume if 3-inch squares are cut out. So that means that my X is 3. So I'm taking my volume formula and I am replacing that X with 3. So this is calculator work. And we're going to type it in just like it looks. Parentheses and all. So we get 2958. We are in units of inches and volume is cubed. We've got inches cubed. So that is my volume. If I take this cardboard and I cut out 3-inch squares. So exact same thing really on C, but now I want to know the volume if I take out 8-inch squares. So now my X is 8. So I've got V equals 40 minus 2 times 8. 35 minus 2 times 8 times 8. This is calculator work again. And because I already have this typed in, I'm just going to come up here and I'm going to replace all of these 3s with 8s. So my volume now is 3648 inches cubed. Now, for the most part, we seem to be pretty good at A, B, and C. It's D that's giving us some trouble. We haven't done a whole lot with calculators. It wants us to graph our volume function, and then it wants to know what is the value of X, which gives the maximum volume of our box. Now, on your question, you're going to have 4 separate graphs as multiple choice. When you have multiple choice graphs, look at your graph right here. I only have the one, but you will have 4 graphs that have almost the exact same thing. Here represents my X min. This represents my X max. Excuse me. This is my Y min and my Y max. So when I graph, I need to change that, and I'll show you why here in a second. So to graph, we're going to go into Y equals, and what do you know? I already have this typed in. So 40 minus 2x, and you have to have the parentheses. Here's your X when you want to put in your variable. Then 35 minus 2x, and then X on the end. Now, if I just hit graph, more than likely you have a standard graph, and so you're going to see absolutely nothing. Other times you might see something just like a straight line, and it's because this window isn't a good window for viewing. So I'm going to come over here to window, and I'm going to change my X min and max, my Y min and max to match whatever graph they give me. So my X min is 0. My X max is 18 right here. And then my X scale, you can leave that at 1. What that means is each little tick mark represents 1. So I'm going to change it to 3 because that's what this one is here. We go 0, 3, 6, 9. Each of these little tick marks represents a value going, it's increasing by a value of 3. And I'm going to come over here and change my Y min and Y max to 0 and 4,000. And again, you can leave this as a scale of 1. The scale really doesn't matter that much, but here I can see these are going up by 500. So I'm going to make this a scale of 500. And now I'm going to hit graph, and now I can see my graph. Not only does using their graph and their X min and max and Y min and max give you a great starting point, but if you want your graph on your calculator to look the exact same as one of the 4 multiple choice, you've got to use their scales and their graph, okay, and their Y min max, X min max. So I'm not going to make this super technical. We got something like that. Okay, probably should have went up higher, but yours is multiple choice, so you're not having to do this by hand, but you know, looks something similar. Okay, so now we need to find the value of which X gives the max volume for the box. So I need to use my calc function here. I'm going to go second calc, And because I want to find the max, I'm going to go to 4. So I can either punch in 4 or I can arrow down and hit enter. So either arrow down, hit enter, or just type in 4 from your pad here. And it's going to walk you through it. It wants the left bound. Well, I know my max is somewhere up here, right? Here's my max somewhere in this area. So I need to go to the left side of it. So I'm going to move my cursor here. Move your cursor. So my max is somewhere in this area. I'm going to go clearly to the left of it. So now my cursor is to the left of that max. I'm going to hit enter, and now it's going to ask for the right bound. So I'm going to move my cursor back over here. My max is somewhere here. So I'm going to go clearly to the right of it over here. Going to ask guess. Guess doesn't mean much, but you can make sure that those arrows are outside and around whatever that max is. I'm going to hit enter. And now I have my max. My max is about 6.2. About 6.2 inches. So what value of X gives the max volume for the box? That's 6.2 inches. And then that max volume that you can get with a piece of cardboard that's 40 by 35 inches is 3,867 inches cubed is the max volume that you can get. Okay, so that's how you answer all of these here. Now, you can stop watching the video. That's all you need to be able to answer the questions. One more cool thing that you want to get pretty familiar with on this calculator is this table. And if you go to second graph, which is your table, you can see your values here. And so if I go to when the volume is 3 inches, that's exactly what we got. We got 2958. When the volume is 8 inches, that is 3648. And so really and truly, once you get this volume generic formula, you can hop right down here to this graphing portion, put it into your y equals, and then hit second table and see your values. So you can either do it by hand and put it in your calculator or use that table function to find these two answers here. I hope that helps you understand a little bit about more what this problem is asking and how to go about solving each of the 4 problems.